Hi everyone, hello and welcome. So in this lecture, I'm going to talk about consumer surplus and producer surplus. Sometimes this area is called welfare economics. It's not a question about transfer payments or welfare as commonly referred to. Instead, we're interested in the well-being of consumers and producers and how they're affected, how this well-being changes when prices change, for instance. So to this point in the course, we've thought about lots of interesting things. We've thought about trade-offs. We've thought about changes in markets caused by shocks to demand or supply. Now what we're going to do is we want to think about how these changes, how these effects are going to influence the well-being of individuals. So what we need to do is introduce terminology that gives us a convenient way to quantify and to think about the effects of price changes on individuals and firms in markets. So we want to think about changes in supply, changes in demand, and how this impacts well-being. So we're going to begin on the consumer side. So I'll introduce the notion of consumer surplus. I'll illustrate it graphically. Then we'll examine producer surplus, look at the producer side, and finally we'll bring everything all together. So ultimately, in the future, what we want to be able to do is extend this reasoning to be able to think about how does government interventions actually affect people in the market. And the important thing to recognize is that be it a price control or a tax or anything else the government's doing, it's not going to affect everybody equally. And we're going to see that here. We're going to see an important way to be able to illustrate and quantify the way that a price change can affect different consumers in different ways, and producers for that matter. Okay, so first some terminology. So a consumer's willingness to pay for a good or service is the maximum price at which they're willing to buy that good. So sometimes we'll use the term reservation price to mean the same thing. So refer to willingness to pay as reservation price. All this means is this is the maximum price at which the consumer is going to buy the good. And remember, we've got this convention where we say if the price of the good is exactly equal to the willingness to pay, the consumer would technically be indifferent between buying and not buying. And in general, whenever we get one of these points of indifference in economics, we'd like to break the tie in favor of the economic activity. So we'll say whatever is my maximal willingness to pay, if the price of the particular good is exactly equal to my willingness to pay, I'm going to buy, right? Okay. Anyhow, so let's see the illustration of willingness to pay using a demand schedule. The important concept is that the height of the demand curve is going to give us the willingness to pay of the marginal consumer. So you can think of the height of the demand curve, how high the demand curve is above the horizontal axis, is giving us willingness to pay of consumers for each of those quantities. All right, so here's our demand schedule. Or demand curve, and then we can build a demand schedule from this information in the table. This isn't technically a demand schedule. We define a demand schedule as having quantities and prices, though using this information, willingness to pay, and our potential buyers, we could figure out the quantity at every price. Well, anyhow, so every graph of supply and demand is going to have price on the vertical and quantity on the horizontal. So here I've got prices ascending by tens and then quantities. This demand curve looks a little unusual relative to what we've seen before. It's not smooth. It's not a straight line. It's a sort of step format. And this is happening because we're assuming we don't have indivisible quantities and we have sort of a small number of consumers in the market. If we had a large number of consumers, this would smooth out quite a bit. Anyway, so the interpretation here, remember, the height of the demand curve is the willingness to pay of the marginal buyer. So we have one person in this market who'd be willing to buy the good at a price of $50. So this is telling us that the quantity demanded associated with a price of 50 is 1 unit. 1 unit. Right? At a price of 50, person A is willing to buy. Right? Willingness to pay is 50 for person A. If the price falls to 40, what this is telling us is that we're going to be able to sell there's 2 units demanded. Quantity demanded is 2 at a price of 40. Who's consuming those 2 units? Well, person A, who had a willingness to pay of 50, is really excited about the price of 40. They're definitely going to buy, so we're going to have 1 unit going to person A, and the second unit is going to go to person B. Right, so the quantity demanded at a price of 50 is 1. Quantity demanded at a price of 40 is 2. The quantity demanded at a price of 30 is 3. Quantity demanded at a price of 20 is 4. And quantity demanded at a price of 10 is 5. Now, I haven't listed quantity demanded other than, these quantities at a given price. We understand these quantities to be the quantity demanded at the associated price. What I've put in the table here isn't quantity demanded. It is the willingness to pay, and then it's who's buying. And from this, we could sort of back out what our demand schedule would look like. Now, we don't necessarily need to do that. Maybe for some particular exercise you would. The whole point of this picture is just to demonstrate, hey, the height of the demand curve is the willingness to pay for the marginal buyer at that quantity. Okay, very good. So, as mentioned, willingness to pay is the maximal price at which a particular consumer is going to buy the goods. So here's how we determine buy versus not buy. So a potential buyer will not buy the good if the price is above their willingness to pay. I mean, if my reservation price, if the maximum I'm willing to pay for a good is at one price and the good is selling for higher, I'm not going to buy. Potential buyer will definitely buy if the price of the good is below their willingness to pay. And they're actually going to be pretty excited about that because they would have been willing to pay more, but they don't have to. Now, if the price is exactly equal to willingness to pay, that person's technically indifferent between buying and not buying. And like I said, we assume consumers buy when they're indifferent. When price is equal to willingness to pay, and reasoning, well, in general, we usually break the ties in favor of the economic activity. So when you're indifferent, we'll say the consumer is going to buy. When the seller is indifferent between selling and not selling, we'll say the seller is going to sell. We're going to break the tie. We're going to break the indifference in the direction of the economic activity. Okay, so how many potential buyers actually make a purchase? Well, I walked through this a little bit a second ago, and we were looking at the picture, but the intuition you should have by this point is, well, the number of buyers depends on the market price. So suppose the market price is $15. We have 4 consumers with a willingness to pay greater than $15. So at a price of $15, the quantity demanded is 4, assuming each person buys at most 1 unit. So if we go back to the graph, and I'll show this on the next slide, sure enough, you'll see a price of 15 corresponds to a quantity demanded of 4. And then once again, the graph has a step shape appearance because we have a small finite number of consumers. Okay, so let's look at that pair. Let's look at a price of 15. Here I've labeled a price of 15. And the quantity demanded associated with the price of 15 is 4. Who's buying? Well, person A, person B, person C, and person D all have a willingness to pay that's greater or equal to 15. Matter of fact, all of their willingness to pays are greater than 15. The only one who doesn't buy, person E. Their willingness to pay is only 10. I mean, the price is too high for them to be willing to buy, so they're just going to ignore it. They're going to ignore the good. Okay, well, suppose the price on the market is $25. Now who buys? At the price of $25, buyer A, B, and C will purchase the good. Remember, person D's willingness to pay was $20. That person's the first one to leave the market as the price has risen. So then my question is, do these consumers gain from the purchase? And how much is their gain? Now, that's a very different question we've been asking before. So far, we've been asking, will they buy? Now what we're asking is, what's their benefit from buying? Have they gained? And how much have they gained? And clearly, it's not the same for all consumers. So in order to assess whether they gain, we have to compare everybody's willingness to pay to the actual price. So let's do this here. First, I'll do this with words, and then I'll show this with the graph. So, okay, let's compare each buyer's willingness to pay to the market price of $25. Remember, these are the same data from the table. Person A's willingness to pay was 50, person B 40, person C 30, person D 20, and person E was 10. Well, if those are their willingness to pays, we'll just deduct the price from that, the actual market price, and we'll see what their gain is relative to the market price. So person A would have bought up to a price of 50. They only actually had to pay 25. So they come out $25 ahead. Person B would have paid as much as $40. The actual market price is $25. They come out $15 ahead. Person C would have paid up to 30. They actually have to pay 25 because that's the going market price. They end up with a gain of $5. What about person D and E? Well, person D's willingness to pay is 5 below the market price, and person E's willingness to pay is 15 below the market price. We wouldn't say their gain is negative. We wouldn't say they have a loss. We're going to say because their willingness to pay is below the price, they're just not going to buy. So D and E don't buy at all. We only have 3 buyers. So our total gain in the market is going to be the sum of the $25 from person A, $15 from person B, and $5 from person C. All right, so the net gain that a buyer achieves from the purchase of a good is their individual consumer surplus. So if we have each buyer, we have their willingness to pay, and I calculate individual consumer surplus. That's a difference between their willingness to pay and the actual market price. So this is just repeating what we had on the slide before. Now, the sum of individual consumer surpluses achieved by all, in the aggregate is total consumer surplus. So at a price of $25, total consumer surplus is $45. Right? We're just adding up the individual consumer surplus from the 3 who purchased the good. Total consumer surplus is 45. Right? So don't make the mistake of deducting, the -5 and the -15 from buyer E and D. They didn't buy. They're not in the market. They don't get any surplus. And we're not going to say that they get a loss simply because, they just simply haven't participated. Okay, so we're going to add up the individual consumer surplus from those who buy, from those who are actually participating. Now, from this time forward, you can refer to consumer surplus to mean both individual and total consumer surplus. So when I say consumer surplus, I can be using this to refer to both terms. I mean, clearly, if we're talking about an individual, meaning individual consumer surplus, if we're talking about the market as a whole or all individuals, then we mean total consumer surplus. Let's just have one term for both because it's really the same concept. Okay. So we can represent consumer surplus graphically, actually. It's the difference between the area below the demand curve and above the market price. The reason why is because consumer surplus is the difference between willingness to pay and actual market price. And remember, the demand curve is just giving us the height of willingness, or the height of the demand curve is giving us the willingness to pay at that quantity. Okay, so then I say sometimes it's useful to distinguish between consumer surplus generated from various buyers. So I'll show that in our graph. Okay, so here's consumer surplus in the market at a price of $25. So here's the $25 of consumer surplus from person A. Here's a consumer surplus, $15 from B. And here's our $5 of consumer surplus from C. Right, graphically, the height of the demand curve is their willingness to pay of the marginal buyer. So the willingness to pay of the buyer of the first unit, the willingness to pay of the buyer of the second unit, and the willingness to pay of the buyer of the third unit. Consumer surplus is the difference between the willingness to pay and the actual market price, which I just said was $25. All right, so I just sum up these areas and that gives us total consumer surplus, right? Total consumer surplus is just the sum of the areas under the curve. Okay, total consumer surplus is $45. And then there's no consumer surplus for D or E. They don't buy, so they're not in the market. All right, now in a case where we have a large market and we have many buyers, our demand curve is going to be smooth. And most of the analysis we're going to see is going to be with a perfect straight line demand curve. In this case, the area under the demand curve is going to be a triangle, right? At least for consumer surplus. So we'll be able to compute total consumer surplus in the market by finding the area of a triangle. And remember, area of a triangle is 1/2 base times height. Base and height, this is just going to be the lengths along the axis. I'll show you that in a second. So look, if we have enough consumers so that we get a smooth curve, straight line, at a price of 25, here's the demand curve. This is corresponding to the willingness to pay of the marginal consumer is the height of the demand curve. Here's the market price. Consumer surplus is the difference between willingness to pay and actual price, or graphically, it's the area under the demand curve and above the market price. Cool, right? So this is a triangle. We can find the area of a triangle. It's 1/2 base times height. So we need this length right here, 50 minus 25. And then we need this length right here, 2.5 minus 0, or 2.5. Why 2.5? Well, I could have drawn this graph a little bit better. I mean, usually if we have a graph, we try to make it a little bit more apparent what this is going to be. I'm pointing at this to kind of help us realize this is 2.5. In my classes, if I was going to have you actually find this quantity by looking at a graph, I'd make it a lot more clear what the actual quantity is. But anyhow, I mean for this right here, this price of 25 to correspond to a quantity demanded of 2.5. Anyway, so 1/2 base times height is 31.25. And yeah, this is different than what we found before. One of the reasons why is now we're assuming rather than just 5 consumers, we have a lot. We have maybe 5,000 or 500,000 or 5 million or something like that. We have a lot of consumers. Okay, so one of the powerful features, though, of consumer surplus is it gives us a rigorous way to identify the impacts of price changes, right? So, I mean, later on in the course, you're going to be interested in thinking about what's the effect of a change in the minimum wage, or what's the effect of a tariff, or going from trade restrictions and protectionism to free trade. Well, the reality is not everybody's affected the same way, and we can quantify these effects using consumer and producer surplus. So let's explore that now. When prices rise or fall, some consumers are affected more strongly than others. So rising prices, of course, means everybody has to pay more, but also some consumers are priced out of the market, like some people are no longer able to buy the good. Falling prices mean everybody pays less. I mean, consumers like lower prices, but people aren't affected the same way. There's a difference between somebody who is in the market and now gets a better deal versus somebody who previously could not afford to buy the good and who now have access to it, right? There's a big difference there, especially from the standpoint of efficiency, which I'll talk about a little later. All right, so previously we had said we had a price of $25. Now let's say we have a price of $15. So what I've done here is first we have the willingness to pay of our consumers. That hasn't changed. Here's consumer surplus at $25. This is a familiar column as well, and here's our total surplus. Now what I've done is I've calculated consumer surplus at a price of $15. This is much larger. That's no surprise. At a lower price, we're going to have larger surplus for consumers, right? And here's the consumer surplus from person A, from person B, person C. Then we drop from the price of 25 to the price of 15. And I've shaded in like a darker blue the gain to person A, B, and C. Like they're better off, no doubt. But there's something different between what's happened to person A, B, and C and what's happened to person D. So person A, B, and C have some additional surplus. They'd previously been in the market. Now they're getting a better deal, and they're happy about that. You better believe that. What about person D? Person D, at the price of 25, the good was too expensive for them. They weren't able to participate in the market. Now the price has fallen. Now they're able to consume that good. Person D is affected differently than person A, B, and C, right? The price decrease brought them into the market. That's different, right? Okay, so that's an important distinction to bear in mind when we're thinking about price changes, particularly caused by the government. And so sort of explore this later when we think about government influence on the market. The influence on individual consumers and producers, though everybody benefits from price rises and price falls on the consumer side, everybody benefits from a price fall on the consumer side. Everybody is harmed by a price rise on the consumer side. Let me be precise there. Not everybody benefits the same way. Some people are forced to leave the market, others are brought in, and that's a little bit of a different effect. Okay, so that's sort of something important to appreciate. All right, so we have analogous terms and concepts that let us analyze the effect of price changes on the producer side of the market. So just like we had willingness to pay for the consumer, and that gave us the height of the demand curve, we have costs, or willingness to sell, for producers, or the producer's reservation price on the seller side. And as you might expect, costs, the height of the supply curve gives us the cost for those units, or gives us the reservation price of the seller for those units. So we'll use, for the firm side of the market, for sellers, we'll use cost, like marginal cost, we'll use reservation price, and we'll use willingness to sell interchangeably, all to refer to the same idea, which is the minimum price at which the seller is going to be willing to part with their product. So graphically, the height of the supply curve gives us the marginal cost corresponding to that quantity. All right, so suppose we have a whole bunch of sellers. We have costs of 50, 40, 30, 20, 10. Potential seller J, I, H, G, and F. So at a price of $10, we'll have quantity supplied of 1 unit. Seller F has low enough cost that they are able to be in this market at a price of $10. Right? I mean, that price exactly equals their cost. Technically, they're indifferent. Once again, we're going to break the tie in favor of the economic activity. So we'll say if the lowest price you're willing to operate at is $10 and the price is $10, we'll assume person F is in the market. Now, if the price rises at $20, person F is still in the market. Now, person G, the price has risen high enough that meets their cost structure. Person G is able to be in the market, or seller C, or seller G. Okay, and so on and so forth. We define the difference between the market price, the actual prevailing market price, and the seller's cost as individual producer surplus. Total producer surplus, predictably, is the sum of individual producer surplus of all the sellers in the market. And just like with consumer surplus, we will use producer surplus to refer to both individual and total surplus, total producer surplus. And as you might expect, graphically, producer surplus is just the area below the market price, the actual market price, and above the supply curve. So we'll see that in a little bit. First, let me develop an example. Let's give us an actual market price to consider. Suppose the market price is $25. Our prospective sellers have the following producer surplus. So I'm going to run down the list. Seller J, their reservation price, their willingness to sell, their costs are $50. If the costs are above the market price, they're not willing to sell. Same thing with seller I. Their costs are $40. The costs are too high to be profitable at $25. We'll assume they're not going to be in the market. Seller H, same story. Their costs are too high. Market price is too low. They don't sell. Right? So we don't say that there's a loss to these three sellers. We just say they don't participate. What about seller G? Seller G has costs of $20. Their costs are below the market price. They're actually able to participate. So they'll sell with an individual producer surplus of $25. This is the market price minus their willingness to sell, gives $5 of producer surplus. Seller F, they have costs of $10. They like that price even better. So they receive producer surplus of market price $25 minus their cost of $10. Individual producer surplus is $15. Clearly, total producer surplus in this market at the price of $25 with these costs is $20. $5 from seller G and $15 from seller F. Okay. So graphically, producer surplus is the area below the market price and above the supply curve. So here's the surplus from seller F. Here's a surplus from seller G. Total producer surplus, $20. And here's our price of $25. Clearly, if the price falls, producer surplus falls. Price rises, producer surplus rises. And if it falls enough, seller G will leave the market. If it rises enough, HIJ might enter the market. Right? If the price rose to above $50, we'd have all 5 sellers in the market. Okay, so we can illustrate the effect of a price change on producer surplus. Suppose the price rises from $25 to $35. Well, all sellers face the same higher price, but not everybody's affected the same way. I mean, all the sellers are going to like the higher price. Sellers like higher prices. Going to get an increase in producer surplus. But these increases in producer surplus aren't the same across all these sellers. Some benefit by being able to join the market, whereas previously they would have been unprofitable. So the change in producer surplus involves gains to existing firms, seller F and seller G. Right? They were in the market before. They like the $35 price better. It also involves gains to a new seller H. H previously had costs too high to be in the market. When the price rises, now they're able to participate and produce and supply the market. So here's this graphically. Here is our existing producer surplus at the price of $25. Now at the price of $35, we have additional producer surplus to existing sellers, or seller F and G. We have new producer surplus to a new seller, H, right? And here again, I've got the individual producer surplus. This column's familiar from before. Here's the column of producer surplus at the price of $35. How is this calculated? Well, we're just taking the costs, the individual costs minus the market price. I mean, the market price minus the individual cost to get producer surplus, right? Market price minus the individual cost to get producer surplus. So price of 25 minus 50 is a negative number. So we say, J is not participating in either case because 35 minus 50 is still negative. When we get down here, $25 minus $20 is $5. So firm G is in the market and receives $5 of surplus at a price of $25. $35 minus 20 is 15. So they're even happier at the price of 35. They get additional surplus. Right? Who's really happy? Seller H. Seller H is unable to participate at the price of 25 because 25 minus 30 is a negative number, minus 5. We just give them a 0, say that they're not participating. However, when the price rises $10, $35 minus 30, minus cost of 30, is producer surplus of 5. That's why I put this in red. Right? Every seller's producer surplus is higher, conditional on them being in the market. But seller H is affected differently because now they're engaging in economic activity, whereas previously they were not. Okay, well, suppose we have a large number of sellers. We could represent the supply curve with a smooth line. Producer surplus is the area below the market price, above the supply curve, and it's a triangle, just like with consumer surplus. Right, so here's our supply curve. Here's our market price at 25. Area of a triangle is 1/2 base times height. What's that triangle? Well, 25 minus 10 is one side, and then the other is this 2.5 minus 0. Right, so 25 minus 10 times 2.5 times 1/2. All right, and this gives us producer surplus of $18.75. All right, we define total surplus as the sum of producer and consumer surplus. Total surplus, when we add together consumer surplus and producer surplus in the market, this gives us total surplus. This is our measure of market efficiency. And actually, we'll say that when the market is perfectly competitive, that'll maximize market efficiency. That'll maximize the sum of producer and consumer surplus. It'll maximize total surplus. Well, anyway, how do we see this? We're not quite at that stage yet. How do we see this? Graphically, total surplus is the area between the demand curve and the supply curve to the left of the quantity that's traded. And it's often just the sum of the area of two triangles. The condition for this to be true is we need downsloping demand, which is almost always the case, and upsloping supply, which is often the case. Though sometimes we can draw the supply curve horizontal or vertical. Okay. Well, here's that standard picture. We have our downward sloping demand curve. We have our upward sloping supply curve. Those are just our plain old demand and supply. You'll recognize our consumer surplus from before, $31.25. And we have our producer surplus from just a second ago, $18.75. The sum of consumer surplus and producer surplus is $50. It's just the area under the demand curve and above the supply curve, right? To the left of the quantity actually traded. What was the quantity traded? Well, that's our equilibrium quantity here. And I mean this to be 2.5. I realize the scale of this picture is not perfect. Well, we'll just have to make do. I'm indicating by these arrows we want the quantity demanded to be 2.5. We want the quantity supplied to be 2.5. Then we're in equilibrium. So total surplus is going to correspond to the area to the left of 2.5 and between the demand curve and the supply curve. Total surplus is always going to be between the demand curve and the supply curve. Consumer surplus is always the area under demand above the market price. Producer surplus is always the area under the market price above supply. Okay. What if we have a shortage or surplus? So a shortage, remember, is defined as a situation where quantity demanded is bigger than quantity supplied. And surplus is corresponding to the situation where quantity supplied is bigger than quantity demanded. In that case, the quantity traded is smaller than the equilibrium quantity. And actually, indeed, when you have a disequilibrium, when you have a shortage, when you have a surplus, the quantity traded is whichever is the smaller of quantity demanded or quantity supplied at that price. Let me say that again. If we have a price prevailing in the market, it's not an equilibrium price, then we definitely have either a shortage or a surplus. If the price is above the market equilibrium, we definitely have a surplus. If the price is below the market equilibrium, we definitely have a shortage. The quantity actually traded is whichever is the smaller of our quantity demanded or quantity supplied at that price, right? And then the leftover or the unmet demanders or unmet suppliers corresponds to the actual shortage or surplus. Well, anyhow, the quantity traded smaller than the equilibrium quantity. Graphically, what this means is if we have a shortage or surplus, the quantity traded lies to the left of where the demand and supply curves cross. That's always going to be the case in the case of a shortage or surplus. As a result, in that case, producer surplus and consumer surplus may involve areas of rectangles as well. Yeah, so sometimes we wouldn't have a triangle. Here's one of those cases. So suppose we have this case. All right, the equilibrium price, it's still the $25. The equilibrium quantity, it's still 2.5. Now we have an above equilibrium price. Suppose we're going to say the price is, what did I say? The price is $30. Yep. So at the above equilibrium price of $30, at the price that's too high, $30, we could find our quantity demanded at a price of $30. I'm saying it's 2. We could find our quantity supplied at a price of $30. I'm saying it's 3.5. Right? So at a given price, you find the quantity demanded by tracing that price over to the demand curve, go straight down to the axis. That's my quantity demanded. Okay, for the supply curve, I'm going to take that price level of $30. I'm going to go over the supply curve straight down. That's my quantity supplied. Oh, quantity supplied is bigger than quantity demanded. That's a surplus. We knew that was going to be a surplus because we had an above equilibrium price. The equilibrium's $25. Price is $30. Sellers like that more than buyers, so we're going to have a surplus. All right, so I say at the above equilibrium price of $30, sellers are willing to sell more. Consumer surplus is 3.5, but buyers purchase less. Quantity demanded is 2. So only 2 units are actually traded, right? When you have a shortage or surplus, the units actually transacted upon is whichever is smaller of quantity demanded or quantity supplied. So in this case, the number of units actually traded is only 2. Only 2 units are actually traded. So relative to the original equilibrium, there's half a unit. 0.5 units are no longer traded. So with less trade, there's less surplus, and total surplus falls, right? These units, the units that are missing between the quantity actually traded to and our equilibrium quantity was half a unit. This little triangle right here. Later in the course, we'll call that deadweight loss. Deadweight loss corresponds to foregone mutually beneficial gains to trade or to inefficiency. I mean, very often we're going to use the first definition, but there's other places where we'll refer to deadweight loss strictly as inefficiency introduced to the market. Often when inefficient sellers are the ones who are producing the good rather than more efficient sellers. We'll cover that during the international trade lecture series or lecture slides. Okay, well, calculating consumer surplus, it's still a triangle, right? Consumer surplus is virtually always a triangle, at least at the introductory level, the types of things that we're going to be doing. So here's the market price, $30. Area of the triangle, 1/2 base times height. So number of units traded was 2. Our price is 30, so 50 minus 30 is 20. So we're going to have 1/2, 20 times 2, or 1/2 of 40, or 20. All right, producer surplus. Well, we do have a triangle. It's going to be this area. We're also going to have a rectangle. Typically on a graph, you'd have sufficient degree of, scale or lines here so you could figure out how to add up those areas. I don't know. So here we have a rectangle, I mean this to be, and then a triangle. We add up those areas. We'll get producer surplus of $25. Total surplus in the market is going to be $45. And what do? We lost $5 in the area of this triangle here due to deadweight loss, comparing our total surplus here to our original total surplus when we were producing the equilibrium quantity. Okay. So, right. The previous picture, we have a distortion because of the fact that the market's not in equilibrium. So we see a loss in total surplus. So this means there's been inefficiency introduced into the market. One way to think of deadweight loss is it's just a measure, just quantifying the inefficiency. So relative to the market equilibrium, there's 0.5 units no longer traded. And this is not affecting everybody the same. So where is this coming from? Where's the half unit coming from? Well, buyers with a willingness to pay between $30 and $25 dropped out of the market, and sellers with costs between $20 and $25 dropped out of the market. Now, what's the problem? Where's the inefficiency? The demand curve over this half unit between the amount actually traded and the equilibrium quantity lies above the supply curve. So this indicates possible gains from trade. It tells us the buyers are willing to pay more for those goods than they cost to produce. Nevertheless, those trades don't occur. So we're sacrificing mutually beneficial trades. That's inefficient, right? These trades would happen at the equilibrium price of $25. The trades don't happen at the above equilibrium price of $30. Price is too high. So that's corresponding to these units right here. Notice these units, these 0.5 units are no longer traded. If the market is in equilibrium, they would be. These trades don't happen, corresponding to this white area, deadweight loss. And it's inefficient because remember, the height of the demand curve is the willingness to pay of buyers. The height of the supply curve is the cost of sellers. These units are valued by buyers more highly than they cost to produce. But yet those trades didn't happen. That's inefficiency, and that's why there's deadweight loss there. Okay, so we'll build on these ideas in the coming weeks in the course. But this is sort of foundational, both for analyzing how price changes and how controls or interventions by the government affects individuals and producers. And the key thing to keep in mind is that not everybody's affected the same way by a price change. I mean, notice this price rose from $25 to $30. Not everybody's affected the same way. These sellers right here, the ones who are still in the market, they benefit. They got a higher price. They like that. These sellers right here, they're no longer selling. They've left the market. They don't like that. What about the buyers? Well, every buyer that's still in the market, this purple area, they have less consumer surplus at a price of $30 than they did at a price of $25. And these buyers are not excited about having less consumer surplus. You better believe that. But these buyers right here, corresponding to this length along the demand curve, they're no longer in the market. They're priced out. They're no longer served. They're more adversely affected than these people because they're no longer in the market. Right? So not everybody's affected the same way by price changes, and we can quantify these effects. We can quantify the gains and losses using consumer surplus and producer surplus. That's exactly the goal of this. Okay, very good.